Algebra 2, Section 1.5, Part 1. We'll do this in 2 videos. This is where things can get a little bit more challenging, especially Part 2 of this section. Right across the top bar, oh, by the way, I did, as I make this video, I haven't done it yet, but I will, when I post this video, put a worksheet that has all of this exactly as you see it here on my Google Classroom, along with the back page will be for Part 2. So you're welcome to download that and print it and do these problems. It's advisable that you would do these problems with me before you attempt the homework. Okay, so on the top bar there, it says if x is greater than or equal to 0, then the absolute value of x is equal to what? And another way to say this is to say that if x is positive. When you have a positive x and you take the absolute value of it, it remains positive. So in this little box should just go x. However, if x is negative, that's what this is saying, then the absolute value of x is equal to negative x, as in the opposite of x. So if x is negative, then we change the sign so that it's positive. It doesn't mean that it's going to have a negative in it. We actually take away the negative. The negative symbol can be thought of as the opposite of. That's what we really mean. If x is negative, then the absolute value of x is the opposite of x. Okay, so how that works then when we're trying to solve equations that have absolute value in it is basically like this. This expression inside the absolute value, it has numeric value, and it could be 12. But also it could be negative 12, because if this evaluated to negative 12 and you took the absolute value of it, it would be equal to 12. So let me say that again. Either 2y minus 4 is equal to 12, right? Because if it's 12 and we take the absolute value of it, it's equal to 12, like it's showing. Or it's equal to negative 12, and then the absolute values have to work to change negative 12 to positive 12. And for that reason, we're going to have to consider 2 cases. So here's what you do. You consider 2 cases. It's either the case that 2y minus 4 equals 12, or 2y minus 4 equals negative 12. And we're going to consider both of those. We're going to solve both of those, and it's going to produce 2 solutions. So quickly, you add 4 to both sides here and divide by 2. One of our solutions is 8. Over here, you'd add 4 to both sides and divide by 2. Our other solution is negative 4. Okay, so we have 2 solutions. They are 8 and negative 4. Now, a word about this word that we're putting in the middle. In Part 2, the word is going to be very important. There is a big difference between or and and. For now, it doesn't matter, right? When it's just 2 solutions, you can use or, you can use and, you can just put a comma between the 2. Point being, there are 2 solutions. That when we get to inequalities, there will be emphasis made on the word or and and. Okay, now, in order to make this work, in order for this to happen, it was because the absolute value was isolated in the equation. So as I look at example 2, we can't do the steps that we did here until we first add 5 to both sides and divide both sides by 3. So I'll do that real quick. Add 5 first. You're going to have 3 times the absolute value of 4w minus 1. And then we added 5 to both sides, so this is 15. And then what you're doing is dividing by 3. And yes, you can do that. You're dividing by 3. The 3's here would cancel. Okay. Now I'm going to try to save space here, so I'm not actually going to keep that, but that is what we're doing. So the right side would become 5. And the left side, then we're just left with 4w minus 1 in that absolute value. Okay, now we consider 2 cases. Case number 1, again, let me just say it one more time. Maybe you didn't catch it the first 2 times, but this is the time for you. 4w minus 1, after I take the absolute value of it, it's going to be equal to 5. That means that the number that's inside here that this is going to evaluate to is either 5 or negative 5, because those are the 2 numbers that when you take the absolute value of it, gives you 5. So either 4w minus 1 equals 5, or 4w minus 1 equals negative 5. And we can just solve for both of those. Here you would add 1 to both sides. 4w equals 6. Divide both sides by 4. That would be 6/4. we always want you to reduce the fraction, so that would actually be 3 over 2. That's one of your solutions. Over here, add 1 to both sides. 4w is equal to negative 4, and then divide by 4, you'll get w equals negative 1. So 3 over 2, which is 1.5, or negative 1. By the way, if you wanted to check those, you certainly can. I'm not doing it on those because it's about to be a direction, you can see on the next example, to check for extraneous solutions. What an extraneous solution is not relevant to these first two problems. You can check it if you want to. Plug 8 in, it'll work. Plug negative 4 in, it'll work. Over here, plug these two numbers in, 4w, it will work. These are the two solutions to each of those examples. Now, an extraneous solution, and I wrote this in before I started the video, is a solution of an equation derived from an original equation that is not a solution of the original equation. Now, that's a lot of words to say this. You did everything right. You got a solution or some solutions, and when you checked them, they didn't check. So that's why I put here in parentheses, it doesn't check. That's an extraneous solution. You didn't make a mistake, but through the process of solving, a solution gets created that actually isn't one. It's extraneous. Okay, so let's see how that works. Here we have another problem, a little bit more complicated than the ones above, but yet it is ready to go as far as the absolute value is isolated. So we consider whether 2x plus 5 is just simply equal to 3x plus 4. Okay? Or it may be the case that 2x plus 5 is equal to the opposite of 3x plus 4. Think about it like if I put parentheses around the 3x plus 4 and made it negative and then distributed the negative, that would be negative 3x minus 4. The opposite of 3x plus 4 is negative 3x minus 4. Okay? Now let's solve. Here you would subtract 2x from both sides. Most people would choose that. And then subtract 4 from both sides to get x equals 1. I always like my variable on the left, so you get 1 equals x. I just flip that around. I think you should do that also. Here, let's add 3x to both sides. So 5x plus 5 equals negative 4. Subtract 5. That would make negative 9 on the right. And then divide by 5. Leave it as a fraction, negative 9/5. Yes, that's negative 1 4/5 or negative 1.8. We like the fraction here. Now, plug it back in. Just a little bit of mental math here. I'm taking 1 and I'm plugging it in for x. 2 times 1 would be 2, plus 5 would be 7, and then the absolute value of that is 7. I plug 1 in here. 1 times 3 is 3, plus 4 is also 7. 1 checked. 1 works. 1 is a solution. Okay? Now, do the same thing with negative 9/5, and you probably would use a calculator for this. 2 times negative 9/5 plus 5, and make it an absolute. Take the absolute value of that, and then plug negative 9/5 in here for x times 3 plus 4. Now, here's the thing. Negative 9/5 times 3, let me just do it real quick, so I don't want to make a mistake, is negative 5.4, and negative 5.4 plus 4 is still a negative number, negative 1.4, right? So how could we ever take the absolute value of something and have it be equal to a negative number? So without even really getting a specific number for both, I can see that since this is going to evaluate to something negative when I plug negative 9/5 in, these are not going to be equal. So negative 9/5 is actually an extraneous solution. Well, listen, for full credit on a problem like this, we can sometimes make this like a 4 or 5 point problem. For full credit, we need to see this accurate number, okay? Negative 9/5 needs to be there, and then you need to label it as extraneous, or maybe your teacher will have you just cross it out. You see, if you only just solved this, if you pretended like the absolute value wasn't there and you just solved it, you get x equals 1, and hey, that's right? Because it's the only solution. No, we need to see that you know to consider the two cases, that you did your math right, you got negative 9/5, and then you went back and checked and found that it was extraneous. Okay, let's practice that at least one more time here. Here we should divide by 5. So the absolute value of 6 minus 5x. And then you're dividing both terms here by 5. This would be 3x minus 7. And then considering two cases, either 6 minus 5x equals 3x minus 7. Just move this over a little bit. That didn't work. Okay, or 6 minus 5x equals the opposite of 3x minus 7, which would be negative 3x plus 7. Okay. Solving. I think we would add 5x to both sides here, so 6 equals 8x minus 7. Add 7 to both sides, 13 equals 8x. Divide both sides by 8, you're going to have 13 eighths. X equals 13 eighths. We think that's a solution. On the other side, go ahead and add 5x to both sides. Subtract 7. And divide by 2. That's going to be negative 1/2. We think we have another solution that is x equals negative 1/2. Now, it's very important that I say this now, that you do need to check this back into the equation that has the absolute value in it. Okay? 13 eighths is the solution to this equation right here. Negative 1/2 is the solution to this right here. You need to check it back at least this far, if not into the original equation. If you want to just keep it as one simple rule, check it back into the original. Technically, you could check it here too. It is the case that extraneous solutions can pop up when we consider the two cases, okay? Now, you've already seen me check one, and you don't want to see me do this again. You probably need to use a calculator anyway. Test it if you want to, but what's going to turn out to be the case is that both of these are extraneous. You see, there is no real rhyme or reason that we know of, that you should know of, that is going to produce both answers true, one answer extraneous and one answer true, or both of them false, okay? So you need to check them individually. Check 13 eighths back into the original equation, check negative 1/2, use your calculator, and you're going to find out that they're both extraneous. Now think about that. If we thought we had two solutions and neither of them actually is a solution, how many solutions do we have? None. And once again, for full credit on a problem like this, we would need to see 13 eighths and negative 1/2, and that you have excluded them. In this case, you should say no solution. Okay. Now, one other thing can happen here, and I do want to do this last problem because there's something else that's kind of interesting here that can happen. And let's see, let's multiply both sides by 3/2 to get rid of this. So that would be the absolute value of 3x minus 6. Multiplying 4 by 3/2 would be 6. And I'll go ahead and distribute a 6 in here, so 6x minus 12 to save a little space. Okay, considering the two cases, either 3x minus 6 equals negative, start with the positive one, equals 6x minus 12, or 3x minus 6 equals the opposite of 6x minus 12, which would be negative 6x plus 12. Solving really quickly. Negative 6 is equal to 3x minus 12. Add 12 to both sides, you'll get 6. And divide by 3, we get x equals 2. Over here, add 6x to both sides. That would be 9x minus 6 is equal to 12. Add 6, 9x equals 18. And divide by 9, x equals 2. Oh, okay. So we considered the two cases, and they turned out to be the same number, right? Now, you still need to check it. The directions should say so. We're still going off these directions up here that say check for extraneous solutions. That will be in your homework as well. And you're only having to check one number. And it does work. In fact, the answer is x equals 2. You can test that on your own. Thanks for tuning in.